Angle properties in triangles. So far we've looked at parallel lines. Now we're going to look at triangles. You might recall from previous grades that all the angles inside a triangle, whether it's A, B, and C, like this triangle, add up to 180 degrees. And that doesn't matter what shape your triangle is. It could be elongated like that with an obtuse angle. It could be an acute angle like this. Or it could even be what's called an equilateral triangle, where all the angles are the same. And if all the angles are the same, and they have to add up to 180, you just divide by 3 to get 60 for every angle. They could also be what's called an isosceles triangle, where only 2 of the angles are equal. So I know that this angle down here and this angle down here are equal. So as soon as I know the top angle, say it's 100, then I know all of the angles have to add up to 180. So if this is 100, there's 80 left over, which means these two bottom angles would have to be 40 degrees each. So it doesn't matter if it's an acute triangle, an obtuse triangle, an equilateral triangle, or an isosceles triangle. They always add up to 180 degrees. So let's look at some examples here. First example I have here, I don't have any parallel lines. We're going to look at that in example 2. I just have a triangle here. And this triangle is made up of actually 2 triangles. There's a big one. There's also a small one on the side here, and a small one on the side here. An obtuse one on the right, a acute one on the left. So I know all the angles have to add up to 180. So what I do is I start with 180. If I'm missing one of the angles, it's simple. I just subtract the other 2. So I subtract off the 28, and I subtract off the 39, which leaves me with 113 for angle X. So this one here is 113 degrees. Now I can use some of my other rules that I know. I know that angle X and angle Y form an entire line. So I know that they must also add up to 180. So again, I start with 180, subtract off my 113, which is the angle over here for angle X. It leaves me with 67, which is the angle for Y. Now I can use my triangle rules again, that they all must add up to 180. So I have angle 64 at the top of this acute triangle. Angle Y, which was 67, I subtract them off from 180. So minus 67, minus 64, and I'm left with 49 degrees for angle Z. 49 degrees. So that helps me find all the missing angles in this triangle. Sometimes I have to use angles on a line that add up to 180, and sometimes I can use the fact that I know that all the angles in the triangle must add up to 180 as well. Let's look at the last example here, or sorry, the second to last example. So I have parallel lines here, which means all my rules for parallel lines apply. So I can see right away that I have a Z angle here, which means that this angle here and this angle here are alternate interior. They're alternate interior because there's my transversal right there going all the way on the diagonal. So I know that angle A must also be 58 degrees. Angle B over here is alternate interior to this angle 48 up here, because again I have this backwards Z. So I know that angle B must also be 48 degrees, equal to that one on the top. So those are done. Now, angle C I can use a couple of different reasons. I can say, you know what, all these angles here have to add up to 180 because they're all on a line. So I could take 180, I could subtract off 48, subtract off 58 to get that angle C. Either way, I'm going to be subtracting off 48 and 58 because if I'm looking at the triangle, this acute triangle in here, I'm also going to say, you know what, that angle C is the third angle, therefore all those angles must add up to 180. So I subtract off 48 and I subtract off 58, which leaves me with 74. Angle D up here, again, I can use a variety of different reasons. I could say that angle D and angle 58 are on a line, therefore they have to add up to 180. I could also say that angle D is interior and on the same side of the transversal to angle 58 down there, so therefore those must add up to 180 as well. So I can take 180, I know they have to be supplementary, subtract off my 58, and it leaves me with 122. Okay, so using all of our rules triangles included with parallel lines as well. Here's the last example that we can look at here. Very, very similar to the example 2. I have alternate interior angle here to 57 degrees. I have an alternate interior angle here to 64 degrees. Angle C and angle 64 are interior on the same side of the transversal. They're supplementary. Start with 180, subtract off 64, and I'm left with 116. And that last angle D at the bottom there, again, I can use a variety of reasons. Let's stick with our triangle reasons. So I have 180 for all the angles in this triangle. I can subtract off 57, subtract off 64, which is the other angle, and I'm left with 59 degrees for this one here. Again, I could have also used the fact that angle D plus angle 57 plus angle 64 all on a line, they form a single line, they have to add up to 180 as well. So all the rules that we have learned for parallel lines will be included, as well as rules for a triangle that add up to 180 degrees.